All right, everyone. As I said, I'm Ryan Smith, head of product here at Deepfence. Thank you for joining us today for our webinar about mastering AI-driven cloud security and what it means for kind of a new era for how we think about and do remediation as security practitioners. With me today, I'm incredibly lucky and humbled because I have Yogesh Badwe, security officer at Druva, joining me. Yogesh, welcome, and thank you for taking the time to join us today.
Thank you for having me.
Excellent. And then I'm also humbled because I have Sandeep Lahani, our founder and CEO. And not only is he our founder and CEO, but it's his birthday today. So we're lucky enough that he chose to spend his birthday talking about AI-driven remediation with us. So it shows his passion for the subject that he's here doing that rather than out celebrating today. So Sandeep, welcome, happy birthday, and thank you for joining us today.
Thank you so much, Ryan. Thank you for the birthday wishes. Excited to be here, Yogesh. Looking forward to sort of dig deeper on this topic with you and Ryan.
Excellent. Well, before we dive in, let's get to just a few housekeeping items. Attendees will be muted throughout the course of the webinar today. The webinar is being recorded, and that recording will be emailed to participants with the slides at the end of the call. We will also take questions. You can leave them using the Q&A of the Zoom feature, but you can ask them at any time. We'll either address them at the end, most likely, or if it makes sense, we'll do it kind of throughout the course of the conversation today. Today's conversation is going to be a panel discussion around a couple of key topics. The first is alert prioritization and remediation, and why these are such big problems for organizations today. How does AI's explosion immediately implicate kind of cloud security, and what will be kind of the first cloud security solutions that adopt AI? We'll then kind of dive into the meat of the topic around remediation and how does AI help us introduce a new area of remediation that's more efficient, leads to better results, and ultimately helps scale our security capabilities as organizations. And then dive into a Deepfence release, which is called ThreatRx, which is a implementation of LLMs and AI models to act as security assistants for us to streamline remediation efforts, whether that be with the patching of vulnerabilities, how those are prioritized within our security posture, or their remediation today. But let's start immediately with this first insight, right? We recently organized a survey of our customers and fellow colleagues in the field. And 90% of those organizations felt that alert prioritization and the ability to simplify remediation in kind of light of all the complexity we see within infrastructure was the number one issue facing their organizations today. So Yogesh, I'm going to maybe start with you here. In your experience as a CISO, how important has this, or how big maybe has this problem of alert fatigue become within organizations? And, how important is getting prioritization correct?
It's a great question, right? I think, it's probably one of the top 5 core problems that exist in the security space, right? And there are a couple of reasons for that. If you take a step back, the security industry as a whole has a problem, what I would call a 100% problem, right? So security teams are responsible for 100% of good outcomes. You won't find a security team there that says that we are responsible for 70% good outcomes, right? So then the question is, how do we achieve 100% good outcomes or 100% prevention? Essentially, it means we want 100% detection, we want 100% investigations, and we want 100% remediation, right? That's tough. It just means that we want to find everything, fix everything, investigate everything, and remediate everything, right? Now, that's one part of the problem. The other part of the problem is we have a volume problem, right? To get to 100% detection, when you think about vulnerabilities, we are already good at trying to find the known nodes, right? If there is a package that we know has a vulnerability, it's not that difficult to find, but there is just too many of them, right? So there are too many things that need patching, too many vulnerabilities that need fixing. And on the maybe the cyber defense detection and response side, companies are struggling with a trade-off between noise and false positives on one end and false negatives on the other end, which kind of again going back to the 100% problem, you need to tip the scale and alert on everything and detect everything to kind of get there, right? So now these two combined together is a lethal kind of state, right? Because what that has led to is you have too many tools, you have too much insight, you have too many things to do, and too few people to do it. And I think that has kind of led to, in many cases, burnout in teams because whether it is the SOC and incident response teams or whether it's vulnerability management teams, there is a lot of burnout that is happening. But even more importantly, right, things are getting missed also, right? Things get missed because when there is too much to do, there is a repeated nature of things where it's possible to either not act on things or not miss things. I mean, there are a lot of stats out there. There's one stat that you have up there. Sometime last year, I came across an IDC stat that said that regardless of the segment of that you operate in, right, whether you're a small SMB company or you're a large enterprise, IDC found on average close to around 30% alerts were being, not acted upon or not missed. And that's again going back to the 100% versus volume kind of trade-off, right? So it's a very critical problem for the industry to solve.
No, I definitely appreciate that insight, and it's something we see organizations struggling with every single day. So maybe Sandeep, I throw this question over to you. After seeing so many customers kind of struggle with this key problem statement, what has Deepfence done to help them kind of identify the critical issues facing them in the cloud today and really prioritize this deluge of information that's coming at them from these cloud security tools?
Yeah, absolutely. I mean, I couldn't agree with Yogesh more. Absolutely everything that he said. I think it applies even more. The problem is even more severe in cloud security, in CNAPP specifically, right? Either you have agentless ways of scanning or network-based scanning or host-based scanning. You're always detecting more that you can fix. It never converges. The more you scan, the more you find. It's a Sisyphean task. And we had done a blog post around that earlier. I remember that. So that's really the problem. So you're not seeing broadly enough is not a problem anymore. You're seeing broadly enough. You're scanning often enough. But ultimately, what do you do with those hundreds of thousands of findings that are being thrown at you every time you scan? And in fact, we're working with some customers, and I think Yogesh can second what I'm really saying here is one of the customers, probably in the top 20 companies, software companies in the world, every time they scan, 40,000 vulnerabilities are reported. One of the financial majors that we were speaking to, 100,000 vulnerabilities plus every time they scan. And we're speaking only about vulnerabilities so far. We're not speaking about CSPM, that's cloud misconfigurations. We're not speaking about malware. You put all of this together, this is a huge problem. And you know what? Ultimately results in burnout. You miss things that you shouldn't miss. You end up wasting time, fixing things which probably are not critical and stuff like that, really. What we realized after speaking to so many customers, so many users of our open source platform as well, is in order to prioritize better, you need to fetch additional telemetry from somewhere. Now that somewhere has to come in either from the endpoint itself, the host itself. It has to come from applications, dependencies, services that are running on that infrastructure. That could be one source of telemetry. The third one, of course, is the actual network traffic. How exactly is our security groups configured? Exactly which ports are open, who's talking to whom, live traffic, who's calling who, API calls and stuff like that. Or you have to get that additional telemetry from, identities, essentially, users, which account, which users, who's doing what, or go deeper in data. So there are 4 or 5 ways you can sort of bring in additional context that you can help to prioritize in a better way. And that's what Deepfence is really doing. What we're saying, look, we already have context from the hosts or the containers in which these vulnerabilities are, found. Yes. Can I also figure out additional context based on the live traffic patterns, live network flows within the cloud? That will really help. And, we'll talk about exactly how. And the third one, of course, is exactly the application context. One, classic example is, and this was such a big problem when Log4j happened, really, and even recently when the SSH attack happened. People knew they were affected, but they did not know exactly how to go and fix. It's like everybody knew they're affected by this vulnerability, but exactly where should I go and what should I do to fix it, really? That was the core problem, more of an operations problem. What we really figured out is being able to tell, like Yogesh was mentioning earlier, this particular package has a vulnerability. That is the easy part. And at a large enough infrastructure, you will have hundreds of thousands of such issues. Being able to tell this particular package is actually loaded in memory of a process which is running in a container. And hey, you know what? That container or pod essentially is configured in such a way in my cloud environment that it can talk to the world, directly or indirectly. And that just makes it more exploitable if the network attack vector, if the attack vector is network really. And that's what we're really trying to figure out. If you just focus on exactly what is exploitable, not worry about just vulnerabilities, but actual exploitabilities, I think you can go from these hundreds of thousands of findings to just a handful that really matter and that you should be focusing right now, not tomorrow, right now, because they're exploitable imminently.
I love that. And I think a major theme you hit on there that, causes complexity, that causes people to deal with prioritization is scale, right? And we obviously see that at the scale of some of the enterprise organizations that we help. I mean, you talk to, hundreds of thousands of vulnerabilities every time they scan. Hundreds of thousands of nodes that they need to protect, millions of cloud resources that are changing. And that's just infrastructure complexity and scale. You throw on the fact that AWS builds 100 new services every month, developers start leveraging. You throw in the fact that people have Kubernetes cloud native infrastructure. They have legacy hosts. They have serverless functions, and they have this in multi-cloud environments. It's a lot to secure. And to Yogesh's point, a lot of times we could have the best processes, the best detection tools and things, but we just don't have the people or resources to handle kind of security at that scale, right? And so let's kind of transition to some of the effects of these kind of problems of prioritization and why they're such a big deal for organizations today. So we see things like 67 to 70% of cloud breaches are due to simple misconfiguration. People leaving the back door unlocked, right? They left an S3 bucket open to the world with customer data in it, and a threat actor walked right in and, just downloaded the file. You also have the fact that because of some of those operational issues that are outside of our control, whether those be, internal ones, people issues, scaling our people and the number of people we have to dedicate to problems, political problems and infighting within an organizations, it takes organizations 49, 50 days to patch critical vulnerabilities. And, threat actors already done significant damage within that amount of time. Even if we take the dwell time, which is the amount it takes for an organization to detect and then remediate a threat actor, that is 21 days across all threats. Now, the rub here, though, is that in 5 minutes, in the cloud in particular, a threat actor has often kind of done the dirty deed and gotten off with what they need to. So with that big of a gap, I want to say, Yogesh, maybe as a CISO, what are some of the operational challenges that you've experienced in your day-to-day life that lead to 49 days? Because like we've all said, detection's easy. We know about these things sometimes instantly. Why does it take so long to patch sometimes?
Makes sense. So, we are, I think, talking about two different themes here, right? One or two different topics, right? One is about patching, and the other is more around, alert or attack detection, so to speak, right? When you talk about patching and finding vulnerabilities, I don't want to say that, it's easy to find vulnerabilities, right? It's probably easy to find the known vulnerabilities. But, operationally, you already talked about some internal challenges that exist in most companies, right? There is a manual triage process involved. There is a manual coordination, prioritization process involved. There are multiple teams involved in the end-to-end process of, from where vulnerability goes from identification to being patched. And then obviously there is a volume problem, right? So not to kind of double hammer on that point, but again, it's a big part of the problem, right? But I think one thing that is crucial that we are missing is context for prioritization, right? So if you think about it right now, or historically, prioritization for vulnerabilities was CVSS based, right? So, CVSS being a standard, people looked at 100,000 issues and said, well, what is CVSS 8 and above, and that's the way they prioritized it. CVSS is basically external context, right? So you are adding external context to a vulnerability. Now, recently, there has been some innovation there. Now, EPSS has come in where that context is getting a little bit more fine-tuned, more refined. So you have CVSS, you have EPSS, and those are all external kind of stimuli to prioritize, 100,000 issues, right? But what is really missing is you don't have internal context, right? For the lack of a word, to just come up with something, I will call it IVSS, like internal vulnerability scoring system, right? Nobody has that. There is no industry standard for internal vulnerability scoring system and to generate that context. And that kind of leads to a lemon kind of problem where there's a lot of asymmetry, right? The triage teams are not really familiar with all the context they need to kind of prioritize the vulnerability. A single tool does not have the visibility to kind of generate all of that context. Right? Sandeep was talking about, the current environments, cloud, where, it's like if you look at the entire technology stack, you really need context from each of the layers of the technology stack to build a prioritization context, right? Whether there is traffic, whether there is something happening in memory, whether there is something happening at the application layer, and you need to stitch all of that together to get very accurate understanding of what is material. Because at the end of the day, that's what we are trying to do, right? We have 100,000 issues. It's hard to fix 100,000 issues. So we are trying to figure out, well, what is material for us so that we can boil down, narrow down, and fix only the things that are material to us. So I think, the same goes, what is true for patching is also true for alert triage, where volume is a problem, but again, context for remediation is a problem, right? If you imagine, many companies have hundreds of AWS and GCP accounts today in the cloud, right? They are owned by 50 different teams for 40 different use cases. And they have infrastructure that is dynamic, constantly changing, auto scaling. With all of this, when there is one indication of a incident, for analysts to go in and really accurately figure out what is happening, accurately scope the incident, and then more importantly, figure out how to immediately remediate it, is not an easy task, right? There's a lot of manual thing happening there where people are going asking questions, trying to log into multiple tools, trying to get that context. And I think, that kind of shows up again and again in terms of the dwell time, because even after you find an alert, and if that alert is even a true alert, right, there is a significant amount of time it takes to really scope and remediate an incident.
That's incredible insight. Thanks for sharing kind of that perspective into some of those operational issues and how many of them stem from a lack of context, right? And Sandeep, that's maybe a perfect segue into my question for you here, which is how can technology better help solve or address some of these operational issues, especially at the scale of the problem that Yogesh was just talking about, multi-GPS, GCP and AWS accounts, different infrastructure that's auto-scaling up and down all the time. Talk about how technology, but specifically AI and ThreatRx can help alleviate some of those operational issues.
Absolutely. I mean, everything Yogesh said, really, two things come to my mind. It really boils down to two things: a meaningful signal to noise ratio that is really useful, which is, and everything Yogesh said, which is about cutting down the volume, really focusing on stuff that matters, having some sort of a logic, which is like IVSS. I love that, by the way. We always make up cool new stuff in these discussions, Yogesh. Always enjoy this. So internal vulnerability scoring systems, for example, really, which is really about the context of your infrastructure, your applications, your identities and stuff that you're putting in to filter out, cut down the volume, and coming to that point where you have, just a set of attack paths, that you're really dealing with. Some of those attack paths are caused by a vulnerability. Some of them are caused because of a cloud misconfiguration, could be a malware, stuff like that. So first part is really that, arrive at a meaningful signal to noise ratio so that your teams are not burning, cycles, chasing unnecessary things that can wait, really. Number one is that. Number two, once you're done with that, how do I reduce the operational burden? Which is where I think LLMs come in picture, Gen AI comes in picture. For example, first start, like think about it this way, right? A new vulnerability was reported. the very first ask or very first task that LLM could do for you is basically just explaining the context in which this particular vulnerability or this particular meaningful misconfiguration affects you as a user, really. Just explaining with additional context that we have gathered, for example, like the runtime context, and also all the context which is out there, that is, about that particular issue. Number one is that could just be a simple start for newcomers in the team, for example, really, right? Number one is that. Number two, you can go ahead and make suggestions around patch versions and how to exactly fix this particular issue. If it's a misconfiguration, maybe emit a Terraform snippet really, or a Pulumi code snippet that you can use to go ahead and run that, patch that particular issue if it's a misconfiguration. Similarly, for vulnerabilities, a patch version, exactly what steps to follow. And oftentimes, what really happens is a lot of these remediations are multi-step workflows. It's never like you just went ahead and installed one package and everything is done. There is something else that has to be done. A lot of that is really, can be automated, has to be, sort of templatized in that way. That's where I think LLM comes in picture, really. Templatizing these multi-step remediation workflows once you've arrived at a deeper or a better signal to noise ratio by using additional context. I think these are the two key things I think all security teams could do. Currently, the way we are doing this, Yogesh, at Deepfence is essentially using LLMs to reduce that operational burden, right? Telemetry collection that is happening elsewhere using REBPF sensors and cloud context and all of that. But right now, the way LLMs are fitting in is basically reduce this operational burden by giving you, code snippets and, think of it as a co-pilot, remediation co-pilot that helps you do all of that. Right.
Yeah, let's dive a little bit more into that use case of how AI can be that remediation co-pilot, particularly in use cases of cloud security. So, we have this graphic which illustrates that AI and generative AI will be used both by threat actors and cybersecurity professionals alike, right? So it will create new challenges, but it will also definitely help make us more efficient as cybersecurity practitioners, right? It helps scale the capabilities of our teams so we can do more with less resources. It solves the cold start problem like Sandeep was talking about in terms of how we enhance our cybersecurity posture. But ultimately, the two use cases that we're going to really focus on throughout this webinar today are prioritization of remediations and accelerating and making more efficient kind of that resolution loop and time. But, Yogesh, as you've kind of encountered a whole brave new world out there of AI kind of exploding like it has, particularly over the last 2 years at the scale it has. What are some of the ways in which you feel that AI will be useful to you as a security practitioner? And, are you like starting to evaluate that with vendors, right, as a feature set or as an enhancement of their capabilities at all?
Yeah, so I'll take up the second question first, right? The vendor, AI is like a storm and it's, just flooding everything, right? So when you look at the vendor landscape, there's hardly anybody who is saying that they are not doing AI. So, there's a lot of noise there in terms of, really figuring out and trying to find products that are truly and accurately leveraging AI to reduce some kind of pain point, right? So pretty much every vendor out there is kind of leveraging AI. But really, I mean, I think AI can be used, the bullet points that you have on the right side of your screen for all of those things very accurately, right? We talked about IVSS, the internal vulnerability scoring system, to get the right kind of context. But if you think about attack detection, response, and remediation, which is the last point, right? Imagine, historically until now, the way that world operates is there is a static run book, right? So somebody writes down a list of steps in a wiki page or a document, and then a junior analyst is opening that up when there's an alert, and then he's going through that steps. Now, that probably worked 20 years back when networks were static and the architecture was static. As we just, talked about before, it's all auto-scaling, dynamically changing, interconnected, interdependent, multi-cloud complex environment, right? So there is no way to have that runbook kind of be that static. The runbook has to be dynamic. And how do you have a dynamic runbook, right? So the only way to do that, it's a knowledge problem, right? The knowledge is changing. You need a system that can parse through a complex set of knowledge base and maybe on the fly come up with a run book for a particular issue and say, look, like based on what we currently see in the network and in the system and how all the pieces fit together, we think this is the run book and this is what a security analyst should do. Now, I think that's really the holy grail. It's easy to talk about and difficult to solve and optimize for. But really, I think the first place where AI could immediately solve a need is to really move tier one to AI, right? Where the tier one tasks, at least the investigative pieces of getting everything together, is being done by AI.
No, that's definitely true. And I think we'll see a lot of those functions, just like we've seen lower level functions and other operational areas across the business get kind of eaten up by AI. That would be certainly one of the first areas to go. But, like you said, there's a lot of noise, but there's still a long way to go for a lot of vendors in this space of their adoption of AI. So Sandeep, why did you all, as a vendor, start with those last two areas, which are prioritization and acceleration or resolution time? It seems like those are kind of basic building blocks, but maybe that's the point.
Yeah, absolutely. I mean, prioritization of scan results, be it vulnerability, be it cloud misconfigurations, be it secrets, or be it malware. I think that is a day zero need of every security, cloud security, right? So it really starts there. You do that, you scan your infrastructure, you prioritize, you fix what has to be fixed immediately, and everything really comes after that, right? Like runtime detection and protection, and everything else really comes. That's really the fundamental building block. Prioritization is the biggest problem within that, which is what we're really trying to address, right, with threat graph. And of course, accelerating the resolution time, really, right, or remediation time, essentially. That's where we are trying to optimize that bit by having LLMs, right, come to our rescue there by reducing that operational burden, removing that cold start problem. Yogesh said it very, very accurately, which is static run books. Nothing about your job now with static. The infrastructure is moving, the traffic is continuously changing, and vulnerabilities are getting reported every hour. So how can you rely on a static run book? And that's where you need something which parses, groks this really complex knowledge base and helps you on the fly. And that's where we are basically adding that. And why essentially for prioritization and reducing resolution time? Because these are the two most severe problems cloud security teams are facing. So we're starting there.
No, I mean, I think we see it every day in the business, right? A lot of companies or vendors are focusing on the scale of their detections, but yet the OWASP top 10 stayed the same for 20 years. We still get popped by 0-day vulnerabilities. People still take 49 days to patch. We haven't solved the fundamentals yet of cloud security. So even the more advanced capabilities are going to stumble and falter a little bit if we can't, prioritize effectively and actually go address the things that we find or detect, right, in a meaningful or efficient way.
Yep.
And part of the reason why it's hard to do that is not just the scale of the infrastructure that we're protecting or the complexity of it, but because of kind of what's represented here is it's a lot of operational process to get from detection of something to prioritizing that to sending it to all of the appropriate teams to fixing scripts and getting those new scripts approved and deploying the fixes and then getting the remediations and policies optimized for next time. And by the time you've kind of gone through that whole cycle, there's a whole new slew of attacks that you have to worry about that are almost make the stuff that you were working on kind of old news. So Yogesh, we've already covered kind of the operational challenges of 49 days to patch, but how much is AI, or what's the opportunity for AI to maybe scale the talent or solve this talent problem? Because I don't foresee us getting more subject matter experts anytime soon, or people's budgets getting infinitely larger. So how much of this is that kind of talent issue and being able to kind of do a lot with the insights that we gather?
Absolutely. I think, talent issue but I would raise something else, right? Security teams are faced with organizational silos also. Organizational silos lead to knowledge silos, right? And it just means no single party has the full context of anything really. So what happens is, if you think the number of personas that play a role in a investigation, you have the security teams, you have incident response teams, you have vulnerability management teams, you have system owners, you have data custodians, you have network architects, and you have engineers developing software, right? And all of these things kind of together play a role when we think about scoping an incident or containing an incident. So usually what security teams do is get everybody on a call and then try to understand, hey, did you build this software? Should it go here? What is the purpose? Or what kind of data is it? Should it be here? What is the architecture? So all of that is a excruciatingly manual process, right? And so if you want to remove those knowledge silos, then that's where I think, again, as we talked about, AI can tremendously help at least get a head start in terms of the understanding that is required to scope and remediate an incident.
Yeah, appreciate that. And Sandeep, can you just explain a little bit about, these pieces down here about building gyros, fixing your Terraform templates, and getting easy to use CLI scripts, right? Part of our problem is like we don't have a Kubernetes network always on hand to, update the Kubernetes networking layer and stuff. So, what ways are you kind of exploring how AI can help with maybe that issue?
No, absolutely. I mean, it's always like, Yogesh sort of, mentioned in the last, I think as an answer to the last question is, do I have a co-pilot or somebody on my staff or somebody who can help me, give me that boilerplate that I can use and see if this is going to fix my problem really, right? Could be a Terraform template, could be a patch version, or, any of those things really. A lot of this is really, repetitive grunt work, right? Like, and you have to do it. There is no other way about it. There is no choice here if it's a critical issue. And that's where I think, LLMs come in picture, AI comes in picture, which is, like I said, there's already, have, grok that knowledge base, and it's not, operational and knowledge base silos Yogesh mentioned. And that is so accurately put really, is that need something which is basically, putting all of this together and, emitting that in a code snippet that really gets you started, right? It could be, hey, run this one command and that's it, you're good. Or, fix this thing in the Helm chart and you're good. Or, run this AWS CLI command and it's done. Or here is a pull me script, which is basically going to take care of all of these issues. All this can be automated. All this can be emitted by LLMs really, right? You don't have to really sit and write codes. If the static run books that Yogesh mentioned again, LLMs are really going to help you make those run books dynamic and ever evolving based on what you're seeing on day-to-day basis, really, right? That's where I think AI comes in picture.
Yeah,
just to add to that, right? I think one point probably we forgot to kind of talk about is just understanding blast radius. That's a knowledge silo problem, but it's not something that can be solved by a human, right? To get just ask somebody and explain what is the blast radius. Because imagine a scenario, you have an incident on a particular machine. How do you track and figure out what's on that machine? If there is a token, what does that token have access to? And then what is the kill chain from that token, where all the permissions go and what all things can be acted upon, right? So that's like going forward problem of understanding blast radius, but that's also a remediation problem, right? Even if you break organizational silos and get people together in a room, it's very hard for that room to come up with what is the most optimal technical solution to mitigate the risk, right? Whether it is let's patch a vulnerability, or whether it is let's block the network port, whether it is take the machine out of circulation, or whether it is change the security group, or move it to a different VPC. All of these things are options, right? And that's a very hard guidance to come up with. As a human, people have to spend a lot of mental brain power to kind of analyze issues and try to figure out what those two things are, right? And AI is the perfect suited for that, because you kind of get that ability to churn through all of these things and pull out that crisp, accurate guidance.
Yeah,
I think it's reusable too, right, Yogesh? And this guidance is reusable as well, in the sense, once a certain issue is triaged in this way, and you build up, basically you add it to your playbook. Next time you see something, similar, you basically ready with the steps remediation workflow that worked for you earlier. It might not work 100% for this one, but hey, look, you're not starting cold now. You already have a reference template that you can use, which will basically solve maybe 75% of your problems, right? You go, you review it, and then it's ready to go, really, right? So that that really also sort of, it's not only about new problems, it's also about similar problems, so this is all reusable templates that you can create with.
Yeah, I love that you both went there because that's where, I wanted to focus here is, sometimes these steps, ideally you would do all of them, right? In an ideal perfect world, and you would patch it and all the teams would cover it, then you would fix your Terraform, and then you would have a new golden image. But the reality of the situation is it's going to take 49 days to patch, but sometimes you can solve the immediate risk to your organization by flipping a security group. And that is easier to do than working with all of these different functions or all of these different steps. And you can do something here that short circuits all of the immediate risk caused by some of this operational workflow and how long it may take to do it. So incredibly insightful. But, I think if I was to sum up some of the insights here is that ultimately it's about reducing operational burden because it simplifies kind of tools, integrations between those things, automations, playbooks. It makes those things dynamic. It helps scale our talent pool and reduce the problem of having subject matter experts in every part of the organization or some of those knowledge silos that were talked about earlier. It can accelerate the time to remediation, decreasing mean time to detection and mean time to response by giving us those scripts, templates, playbooks, and helping us change without having to involve necessary people all the time, where there would be manual effort. And then it allows us to ultimately have and apply this to us, right? And our environment, our context, because not only AI is the accumulation of human knowledge to an extent, but it's also the accumulation of the knowledge that we feed it. And so if we couple that with runtime context, application network traffic, and things like that, then we can get to some of these questions that would often take, a human a long time to decipher. But I want to spend a little bit of the last part of this webinar really walking through how Deepfence with ThreatRx, which is a feature in our Threat Striker platform, Elite helps us with the remediation of critical security alerts. And Cindy, I really want to start with you on this one of, how Deepfence really thinks about prioritizing security findings along with AI, not only to help organizations build an internal threat graph of their attack surface, taking those thousands of issues down to the 3 that you should be looking at, but then how Threat RX helps remediate those attack paths and vectors and really shortens the whole cycle here. So maybe, just take a few minutes, explain the Deepfence platform and what you all are thinking about with Threat RX here.
Yeah, absolutely. In fact, the picture that you see in front of you right now essentially has both of those critical pieces. The first piece essentially is how do I go from hundreds of thousands of scan results to a handful that matter, and also in a manner that is imminently actionable, in the sense, can I go from a flat list of a few thousand vulnerabilities to attack paths which are live and ticking, in the sense they're really derived from additional telemetry that you're gathering from the infrastructure, like network traffic. You're looking at what is loaded in memory, of course. Hey, here is a particular vulnerability. It's actually in a package which is loaded in memory. The security groups are configured in such a way that traffic can actually reach here from outside. So you really figure out that north-south attack path. An attacker can exploit this from outside of my infrastructure now, because hey, the vulnerability is locked and loaded. The traffic HTTP request can actually reach this particular node where this particular vulnerability is loaded and stuff like that. All this additional context gets you what we call as threat graph. Threat graph is basically a exploitable subset, immediately exploitable subset of all of your attack surface, which is derived by scanning for vulnerabilities, for cloud misconfiguration, sensitive secrets that might be lying around in your container images or on your host. and of course malware, really, right? So that's the first part. That is called threat graph. Now, just imagine if you had an ability to right click or just say that, hey, I see few attack paths which are live here as per threat graph. Can you actually help me remediate all of those, right? Now, or some of those like that you find more meaningful or more urgent, really. You can say that, hey, you know what, this particular attack path which is coming in from outside and actually going to this particular pod where I'm running my critical service, can you remediate this? And threat RX comes in picture there. What it is going to really do is it's going to take all of the context that it has about the vulnerability or malware, whatever is the reason for that particular threat attack graph to exist. It's going to look at how your security groups are configured, how traffic is really flowing. Traffic is live, of course. You're going to look at all of that, and then you're generating a remediation plan based on that live attack path, which is there. This is so different from this is so, think about the other case, right? Which is what we've been doing traditionally. Here is a vulnerability, and then you go to the security advisory and figure out a patch and you run it, really, right? That's an old school way of doing things. It doesn't scale. We know that by now. What we're really doing is going from that, like I said, hundreds of thousands of vulnerabilities to a threat graph. And threat graph, every live attack path, you should be able to remediate, generate that multi-step remediation workflow for each and every attack path. As of now, we're doing north-south attack paths, but the same technology can be applied, like Yogesh was mentioning earlier, to lateral attack paths or the blast radius, right? Hey, I know this particular pod is talking to that particular S3 bucket, and not only it has a vulnerability, the S3 bucket also has some sensitive data, stuff like that. You can also figure out the blast radius and apply the remediation essentially using ThreatRx, not only for the north-south attack paths, but also figuring out the whole blast radius and remediating it, really, right? So that's really what we're doing with Deepfence. Threat graph is something that we launched even in open source almost, it's been more than a year, and it's really getting tremendous reviews because people are able to sort of, go from, those thousands of scan results to just meaningful stuff. And ThreatRx is something that we launched about a month ago, Ryan, right? Which is basically, adding remediation on top of this attack graph that is already built using the additional runtime context.
Yeah, no, appreciate that explanation and overview here. So Yogesh, when we think about runtime context, particularly, how it helps us filter insights within our environment, I think what you've said a few times on this webinar so far is, sometimes the easy part of security is the known knowns, right? The things that we know are bad and things like that. But, sometimes this is what a zero day is. We didn't know something existed. It's within the infrastructure. We know it's everywhere because it's in a library that is, throughout the entire open source stack and things like that. How is that context important in identifying what to do in those scenarios where a patch might not be identified yet? And so you need to know, hey, this new outbound connection opened up, and that's certainly weird, right? Because that hasn't happened in the past 60 days, or now we have these new communication patterns within the architecture, or stuff like that. So just talk a little bit about that runtime context and why this visual representation of it is so important in your role as a CISO.
Absolutely, right. I think when you say runtime, there are two different facets to that. There is a system runtime, right? And then there is a network runtime. And I think, to accurately understand what is going on, you need both of those things together, right? So again, I think we have talked about this before, but for bad things to happen, something has to be first loaded in memory. There has to be a port. There has to be incoming traffic to that port, and that traffic has to be malicious in nature, right? And if all of those things are true, then maybe there is partly a problem, right? Now, if there's outbound connection from the same place, right, and it's going to if you add external context and say, well, that IP or that domain is again suspicious, then you are adding a lot of different types of insight to kind of pretty much confirm that there is a problem going on, right? Without the network context, you just don't know, right? There might, imagine a scenario where there's something loaded in memory, but that it has never received any traffic and it is not currently receiving traffic. So then maybe it's a prioritization issue, right? It can help you prioritize, but it's not really an active problem that needs to be solved. or maybe, as you guys talked about, that there is a package with a vulnerability, and there is no lack of those, right? There are the hundreds and thousands of issues that come up again and again, but it's not even loaded in memory. Then why should we care about it? Developers and technical operations, cloud operations teams, they are kind of supporting the business, right? And you don't want to kind of waste time by kind of whack-a-mole approach, where you are just, because you don't know how to prioritize or how to remediate accurately, you are just saying that let's prioritize everything and let's remediate everything, which is probably the more costly solution for the business. Because if you really want to be more efficient in terms of the time required, then you need to accurately point out what needs to happen.
Oh, definitely. I mean, there is a ton of time that could be spent towards core business functions, maintaining applications that are important to revenue functions and things like that, that is spent on compliance management and patching and reporting within DevOps organizations today. So that's a very real issue. So let's walk through that life cycle. You just talked about it, Yogesh. There has to be a vulnerability. It has to be critical and severe and active. It has to be loaded in memory. There has to be an attack path to it, so it has to be accessible. So you have to identify both of those things. And then, there has to be, the ability to see the traffic for when it actually is exploited. So when is a threat actor actually utilizing a certain TTP? So the next few slides are going to walk through a very famous example that we're all familiar with, probably almost beat to a dead horse at this point, but it's very clear and easy to understand in the context of what we've been talking about, which is log4shell, right? So we had this zero-day vulnerability. Even before it was kind of known what the patch and remediation is, we knew that the outcome of this type of vulnerability would be remote code execution behavior. So, we wanted to see this vulnerability kind of loaded in memory and then detect it. So, Yogesh, to you, CVSS severity have been long the benchmark for security, but you talked about it. How does context, having that IDSS, help us determine actual risk versus potential risk? And, particularly in the case of like a 0-day, why is that so important to do? Because you had 1,000 instances of, hey, you got log4j everywhere. Now what? Do you go tackle all 1,000 of those, or how do you determine, what's important out of those 1,000 hosts that might have that?
Absolutely, right. I mean, I think, again, think about it this way. I think, it was December when log4j happened, maybe 2 years back now, right? And so in December, you have teams running 24/7, trying to figure out where they have an issue and how to patch it quickly. And patching, it's easy to say, but it's extremely hard and complex. It's not that straightforward, right? Systems don't run in a silo, in a vacuum, in isolation. They're all interconnected. So patching is a hard problem, right? So, if you think about log4j, that insight of, well, you have 100,000 instances of log4j in your environment, but only 100 of them are actually currently loaded in memory, helps you prioritize, well, let's focus on these 100. If there is no network path to those instances, or if there is no north-south network path, right? I mean, I think there is a distinction to be made in terms of severity between what is externally reachable versus what is east-west reachable, right? So there is another context that you can use to prioritize those 100 issues even further down, to say that, look, out of those 100, there is east-west network path for all 100, but only 10 of them have a north-south network path from outside your network coming into inside. So you are further narrowing it down to the 10 that you immediately need to fix. And then, potentially you could use the blast radius and additional context for kind of prioritize those 10 as well, right? So some of those assets might have access to sensitive data, or they might have IAM roles assigned, which roles can have downstream access to more critical systems, right? And you can use all of that context to really narrow down. I mean, I think I'm coming up with numbers out of a magic hat, but boil down to 5, right? So you quickly drastically reduce the immediate workload you need to solve. Now, I wouldn't say that means your job is done, right? So we can't just fix 4 issues that are kind of the most critical and call it a day. But you can definitely help use that and leverage that to say that, look, like, these are the 5 you need to immediately fix over the next few days, while we come up with a more business friendly, less impactful plan to kind of remediate the potential risk also, right? So for something like log4j, you probably need to remediate all risk, because as we said, things are not static. So something that is potential risk right now can become an active risk because something changes, and so you don't want that to kind of pester around as a potential risk for a very long time. But again, that this context can help bubble that up also, right? Imagine you fixed all of the log4j issues that were an active risk, and then the rest were not loaded in memory, or there was no attack path, and then kind of, even if you waited for fixing those, if there is a change that in the system that kind of creates that attack path at a point in time, you can bubble that up and increase the IVSS score, so to speak, and say, look, like this is now IVSS 10, right? So you need to kind of take a look at that. So all of those things will be super useful.
No, I think you covered, what I was going to cover with Sandeep was, all of that lack of context really leaves you blind, right? If you are just using kind of maybe a traditional host-based vulnerability scanner without kind of looking at those configuration changes, the network traffic, what's loaded in process and memory, and things like that. So really almost modern kind of or vulnerability management's undergoing kind of an evolution right now, to where if you just use those kind of legacy tools, then you're going to be left blind to a lot of important steps for prioritization. And then on the remediation side, obviously, this is exactly what Sandeep was talking about earlier, what we have up on screen in the screenshot, which is here is a CLI script, which gives you a quick way to check and update libraries related to log4j configurations. So this would be an issue of addressing, kind of that risk at the patching level. But we may not even need to actually do that for all of the risks right away, which was what Yogesh was getting at, was that sometimes there's a configuration that's allowing access. So I think you said there was, like, maybe in your fictional math, 10 of these EC2 instances that have public IP addresses, that have traffic that's kind of live with them, right? So maybe actually addressing this configuration change with a Terraform script would be the quickest path to remediation. So having that additional context really helps us kind of do that. But Sandeep, maybe talk to us a little bit about what having, CSPM data in a threat graph does for companies, and why you kind of incorporated CSPM, malware, secret, vulnerability data all into kind of a contextual picture for organizations.
Yeah, absolutely. I think these four, the ones that you mentioned, which is vulnerabilities, cloud misconfigurations, malware, and sensitive secrets lying around, these are the four fundamental types of scans. Of course, there are more, and a lot of CNAPs also go deeper in data and elsewhere. But I think these are the basic building blocks. That's where you need to start. More specifically about what is the meaning of an attack path when it comes to a cloud misconfiguration issue, really, right? I think it could be two simple cases, really, right? A lot of this has been covered already, but here is an S3 bucket, which is being used by one of my services, where it is writing, sensitive data. It's dumping sensitive data, and hey, you know what? It's open to the world. Very, very simple, very basic, CSPM 101 kind of an issue, really, right? This is a clear-cut north-south attack path. That this is a S3 bucket which is misconfigured, and anybody could do it. You go a little deeper, and then you start seeing these indirect or lateral attack paths, also called blast radius, which is where you start seeing things like, hey, what? Here is a vulnerability in a package which is running, in a certain pod, and that pod is running a critical service which is dealing with PII. And hey, you know what? It is also accessing this S3 bucket, which is not directly exposed to the world, but now it has become part of that whole blast radius because of this vulnerability, which was really, which was basically exploitable. So ultimately, it all comes down to that IVSS scoring mechanism that we have come up with. IVSS 7 is immediately exploitable compared to CVSS 9. If CVSS 9 is not really, accessible to attackers, because it is not, in a running node or container or stuff like that. So ultimately, yeah, when it comes to CSPM, I think these are the two examples that come to my mind, Ryan.
Yeah, I love that. Appreciate that insight. And ultimately, that leads us into actually neutralizing the threat. So what we're going to actually see is the JNDI to LDAP connection, which is the runtime incident. and there's going to be a couple of ways of neutralizing that threat, right? And holistically throughout that life cycle. In the moment, you might want to filter network traffic or quarantine a workload. Ideally, you patch the thing. Then you could make a configuration change, ideally, to prevent the network traffic. There's a number of steps. So AI not only helps list those various steps and options for us or strategies, it can help us prioritize those different strategies as well, leveraging that kind of context that we had before, and give us kind of the best solution to what we were seeing, even if it's not the options that another organization would take. It's the options that make the most sense for us. And I think that's really the way in which we'll see AI being used as kind of a hyper analyst or kind of a security analyst that can kind of be queried with ultimate knowledge of the organization's security posture, regardless of those knowledge gaps, silo gaps, security gaps that Yogesh was talking about a little earlier. So, I think this has been a very interesting and thoughtful discussion. So, Yogesh and Sandeep, I deeply appreciate you joining us today. Before we get to just a few questions we have in the audience, I'm going to maybe turn it over to Yogesh for any closing thoughts you might want to leave the audience with, or things that have come up in today's presentation that you think were particularly insightful that people should take away as a few key takeaways.
Yeah, I think, zooming out, right, broadly, a lot of the things that are a problem in the security world are knowledge problems and knowledge summarization problems, and how to effectively use summarization of knowledge to kind of some kind of action or a workflow, right? So that kind of, it takes care of a lot of different issues, right? So I think as we move forward, we'll see a lot more applications of these. There was a question around zero trust. Maybe just quickly answer that in that context as well, right? Zero trust is probably a much broader kind of framework. So probably need another hour to just talk about zero trust and AI and what things can play a role there. But imagine the same scenario, right? Like you have authentication, and you need to have continuous authentication to systems based on the context that you have for the endpoints or for the servers that are authenticating, right? And that real-time context, generating that in terms of, hey, if you take the example of an endpoint, what is the posture of the endpoint? Are there any security issues on the endpoint? Is there any active attack going on the endpoint? What about the user? Is he being targeted? And just pulling all of that together in the authentication context is a similar kind of application of generative AI to solve a different set of problems.
No, appreciate those closing thoughts. And once again, thank you so much for lending your valuable time and insights as a security practitioner to this discussion, because I think it's something that we don't hear enough from as the practitioners themselves and how this is impacting their daily lives. I think we make a lot of assumptions about it within the vendor landscape, but it's great to hear from security thought leaders themselves, which is what this whole webinar series has been about for Deepfence. Sandeep, as always, thank you for leveraging your insights as a founder in the space who's actively building products to solve those operational challenges for organizations. I know we had a few more questions that we will follow up answers to as we send out this recording and the slides to this. So we will make sure to get all your questions answered, but I do want to be respectful of everybody's time today as we run up against the hour. So thank you, everybody, for joining the conversation today. The last things I'll leave you with is if you want to try Deepfence, please go visit deepfence.io. You can visit the Get Deepfence page, and you can get started with our Enterprise Edition, either cloud or on-prem. And as well as our open source edition, which is used across multiple organizations around the globe, has 1.3 million people kind of leveraging its tools, and has been a great kind of start in the fundamentals of cloud security for enterprises today. So thank you for the time today. Thank you for the deep dive into this discussion around how AI can help us master remediation given the complexity and scale of the cloud. And we'll catch you next month for our next webinar in this series.